for starting three-dimensional geometry. First, recall some important concepts based on vectors. Okay. So in vectors, we discuss this concept. If we have any directed line segment, that directed line segment is known as vectors. Where the length of that direct line segment is known as the magnitude of that vector, and the direction of that line is known as the direction of that vector. So normally in every vector we have two important characteristics. First one magnitude, second one the sense or sense of direction, or we can say unit vector for this. So in every vector we have one part magnitude, other part direction. In this case, when we have unit vector, in unit k, for example, if vector A is given by ax of ik plus ay of jk plus az of kk. Here ax, ay, az are normal scalar component of vectors, while ax, ik, ay, jk, az, kk are vector components of the given vector. So in this a cap is what? That ax divided by magnitude A. Magnitude A is always ax square plus ay square plus az square. So here a cap is ax by magnitude of A of I cap plus ay magnitude of A of j cap plus az magnitude of A k cap, where magnitude of A is always ax square plus ay square plus az square. This in unit vector. In vector we already discussed that concept. In unit vector, the component of I, j k or component of x, y, z, or we can say coefficient of I cap, j cap, k cap. Here these values are known as this value, and this value are known as our L of I cap plus M of j cap plus N of k cap, where L11 are known as the direction cosine. We already discussed that concept. So these are known as our direction cosines. So we are normally representing them by DCs. What are the direction cosines? As the name suggests, cosine. That means these are the direction in terms of cosine value. So direction means angle and cosine. So 11 are logically our cos alpha, cos beta and cos gamma. So this value is L, this value is M, this value is N. If we have any vector A in 3D, this is our x-axis, y-axis, z-axis. These x, y, z axis are known as rectangular coordinate axis. All three are mutually perpendicular to each other. So here if we have one vector, vector A, this one. So that coefficient of this head is ax comma ay comma az. So coordinate of this vector A or point A is given by x, ay, az. Here this, if x-axis having some angle alpha with this vector, y-axis having angle beta with this vector, and z to this side, z to this, and this vector is gamma. So here these alpha, beta, gamma are known as our direction angles. Alpha, beta, gamma are our direction angles, respectively with x, y, z axis. Alpha, beta, gamma, cos alpha, cos beta, cos gamma, or we can use the term L11, where L11 are our direction cosines. So this value cos alpha, cos beta, cos gamma, and we can calculate the value of L11 by using the direction. Direction means unit vector. Unit vector means a vector whose magnitude is 1 is known as unit vector. So by that logic we know that this vector's magnitude is 1. So we can write this value square plus this value. The magnitude of a cap is 1. So by that logic we have one important relation here. Cos square alpha plus cos square beta plus cos square gamma is always 1 by the concept of unit vector. This value is cos alpha, cos beta, cos gamma. or even in terms of element we can write this value as L square plus M square plus N square equals to 1. So direction, cosine and direction angle, alpha, beta, gamma are direction angles, while the cos alpha, cos beta, cos gamma. Now one important point, on this vector we have infinite, on this line segment, directed line segment from O to that point A, whatever point is there, O to point A, we have infinite points, okay, on this line segment. Every point shows, the coordinate of every point is known as what? The coordinate of every point on this line segment, either in this direction or this direction. Okay, so we have this directed line segment is what? Our vector. But actual line of support of what? For this vector we have this line. So actual the line of this vector is this one. This side up to infinite. Same for this side also infinite. So every point on this line is our direction number. So what is direction number or direction ratio? In our book normally we are using the term direction ratio. So direction ratio, direction number is what? Every point situated on that line is given by direction ratio, direction number. It is what? So logically direction ratio, direction numbers are normally represented by small abc, even capital ABC also. ABC are our direction ratio, direction number. So it is a number which is proportionate to our direction cosines. So we can say ABC are what? So direction ratio is a number which is proportionate to direction cosines. So proportionate to direction cosines. So when we are using the proportionality constant, for example, equals to some lambda of that value DC. So logically A is what? Lambda of L, B is lambda of C, B is lambda of M, C is lambda of M. So here we can say direction ratio, that means when we multiply by any scalar quantity with direction cosine, like LMN multiplied by 2, so 2L, 2M, 2N. Every point, logically every point on this line, which line? The actual parental line on this vector. So we have only this line segment, that is directed line segment, that is the length of vector. But on this line we have infinite, even on this segment also we have infinite point. But on this line maybe in this same direction or opposite direction. So direction ratio, direction number is what? Every point situated on the parental line of the given vector is known as direction ratio, direction number. But how we can calculate that direction ratio, direction number? In our books we have this definition: a number which is proportionate to direction cosine is known as direction ratio, direction number. So normally we are representing that direction ratio, direction number by ABC. Now, so very basic direction ratio is what? When we are saying every point on this line segment. So we know that this first point, the source of this point which is 0, 0, same this is final point, or we can say head of this is AX, AY, AZ. So every point on this, that means every head is also our one direction ratio. So in this case A vector we can say this coordinate is what? The coordinate of this A vector is AX, AY, AZ, this point. AX, AY, AZ is also our one direction ratio. Direction ratio, direction number are infinite for a reference of one vector, but direction cosine is unique. Again, for a vector direction cosine is unique, but for a line direction cosine is two type of values. First one this side and second one is opposite of that case. So if we have direction cosine LMN for any vector, then corresponding line we have two type of direction cosine, one value with LMN and second value the negative case of this, or we can say minus L, minus M, minus L. So in case of line, but if line is given by directed line also, okay, that means for line we have direction. So we can say direction cosines are unique in case of vector as well as directed line. If line is not directed, then we have two type of direction cosine, one in plus direction, other is just opposite, so make minus of this case. That concept, because for this side if we have this angle alpha, so from that case, from that side we have angle pi minus alpha. Cos 180 minus alpha is minus cos alpha, so that value is minus L, minus M, minus M. So direction cosines are unique in terms of vector as well as line also. Okay. But logically, if line is not directed, then we have two type of case: element and minus L, minus M, minus N. Just converse direction or opposite direction of this. Direction cosine is unique. Same. Direction angle is unique for in terms of vectors. Even for line also. Second type, pi minus alpha, pi minus beta, pi minus gamma. That linear pair axiom concept. But direction number or direction ratio, which is given by ABC collectively, it is numerous or infinite. This based on the different value of lambda. So very basic direction ratio number is what? A given head or given point. So here for this vector we have this head value ax, ay, az. So we can directly say this is our direction ratio, direction ratio, direction ratio, a, b, c. Now one important point: this ax, ay, az in terms of vector, this ax is what? We can say this ax is projection of vector A along x-axis. This is what? Ax is what? Ax is projection of A along x-axis. Now check. We have this vector here. This is xy, this is z, and here we have this vector A. So projection of A along x-axis. So when we multiply this A vector with the direction of x-axis, check. Ax I cap plus ay j cap plus az cap dot of I cap only, dot of I cap. So I dot I1, that value is only ax. Clear? So ax means direction of one vector with respect to other vector. So this concept A vector dot of B cap is what? A vector dot of B cap, logically mod A cos theta. Okay. So we can say when we have ax equals to mod A and this is cos alpha, check. Ax by mod A is cos alpha, so ax is what? Mod A cos alpha. So we can say this is projection of A vector along x-axis. This value is ax. Ay is what? Projection of A vector along y-axis. So this angle is this one, this length, mod ay or mod A cos alpha, and this az is what? Projection of A vector along z-axis. So ax, ay, az are what? First, ax, ay, az we can say direction ratio. First case, direction number also, coordinate of that point also, and even we can say these are projection along x-axis, projection along y-axis, projection along z-axis. Ax, ay, az. Because ax is what? Ax by mod A is cos alpha. So when we write ax is what? Mod A cos alpha, and we know that take the mode of any vector and angle between them. This angle is alpha, so that is projection. So after simplification, this is what? We know that this case is mod A cos theta, if A and B having angle theta. So for this ax by mod A is cos alpha. This case ax by mod A. So mod A into cos alpha is projection, that is ax. So ax, ay, az is also projection. Okay. Now in 3D, first important point. First, if vector is given, now in terms of position vector of 2. So position vector for example, if we have one vector A, other vector B, and we have the corresponding position vectors of vector A as well as vector B. This is our first part, this is our second part. So by using triangle's law of addition in vectors, we can write this is OA vector, this case, this is OB vector, for example A vector, this is B vector, this. So by using this side plus this side, resultant sum. So this value is OA vector plus AB vector. Third side is the resultant side is OB vector. We can write AB vector as what? OB minus OA. If B vector is given by x2, y2, z2 and A vector is given by x1, y1, z1, so the vector AB is what? Position vector of B minus this one. So OB vector is x2, I cap, y2, j cap, z2, k cap, x1, I, y1, z, z1. Directly I am writing x2 minus x1 of I cap plus y2 minus y1 of j cap plus z2 minus z1 of k cap. AB vector is what? So here this is AB vector Now same. Every time we are saying what? In every vector, the component of I cap, j cap, k cap or scalar component of x, y, z axis are our. We just discussed that concept. These are direction ratio also. So we can say here this is our small a, small b and small c. So we can write the direction ratio of AB vector line is what? That is ABC. So this value we can write in terms of x2 minus x1, y2 minus y1 and z2 minus z1. This is vector. If we will calculate the magnitude of this AB vector, so we know that the AB vector is what? Magnitude of AB vector is also root of component of I cap, component of j cap, component of k cap. Or scalar case of x axis, scalar component of y axis and scalar component of z axis. This is our magnitude. And by the definition of unit vector, when we divide AB vector by magnitude, so we have this value. So x2 minus x1 this value, y2 minus y1 this value and z2 minus z1. Here we know that this is ABC, so we can write this value as a square plus b square plus c square. Also in terms of direction ratio. So here direction or unit vector or direction cosine is what? Check. Direction cosine, or we can say LMNR what? So LMNR logically what? We have to divide this value. But again important point, if we are working on vector, then it is unique. But if we are working on line, then maybe direction on this side or direction on this side. Either I can write BA vector as a OB, BA, then OA, that type of format. So in this vector, in terms of line, we have LMN value as this one, A by root of A square plus B square plus C square, B by root of A square plus B square plus C square. It is nothing but same, that AX divided by magnitude A. Here magnitude A we are writing in terms of direction ratio. Directly we can write this value C by root of A square plus B square plus C square. If we have in same direction, then that value is same element. If we have opposite direction, like BA vector x1 minus x2, so we have two type of cases every time. Plus minus, plus minus. So in terms of direction cosine of line, we can use that value plus minus A plus minus B plus minus C divided by magnitude of this, or magnitude we can use this. So directly for every vector we can find direction cosine. Direction, again I am repeating, direction cosine what? Always find the unit vector for given vector divided by magnitude of that. So here the component of x axis, component of j and component of k, or we can say coefficient of I, coefficient of j, coefficient of k is known as our LMN or direction cosine. These are cos alpha, cos beta, cos gamma. We have alpha, beta, gamma are our direction angles, and we have, due to this unit vector, we have this property. The magnitude of this should be 1. So root of cos square alpha, root of cos plus cos square beta plus cos square gamma 1. By squaring we have this value. In terms of LMN we can write this. Even we can write this in terms of sine. If we will use class 10 formula, 1 minus sin square alpha, 1 minus sin square beta, 1 minus sin square gamma. So by this we have one other property based on sine. 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma equals to 1. So 1 to 1 cancel out. So we can write this in terms of sine is sin square alpha, sin square beta, sin square gamma equals to 2. For cos we have value 1, for sine 1 to 1, 1 is cancel out and 1 and 1 2. Take all minus in right side. So sin square alpha plus sin square beta plus sin square gamma equals to 2. Where alpha, beta, gamma are our direction cosine. Alpha, beta, gamma are our direction angles. While cos alpha, cos beta, cos gamma are direction cosines. And even we can say sin alpha, sin beta, sin gamma as a direction sines. But normally we are not using that term. Only DC, DA and DR for direction number. ABC, we can find the value of ABC by using this. So direction ratio numbers are what? These are infinite in terms of a vector or in terms of line. While direction cosine is unique, even in terms of line, in terms of vector. In terms of line we have two type of value, one with plus, one with minus. for opposite direction and same direction. 1 2 3 now. So before starting line again, if two vectors are perpendicular, a vector is perpendicular to b vector, or two vectors, two lines, two planes are perpendicular, then their dot product should be always 0. A dot b equals to 0 due to that cos 90. But if we have a vector parallel to b vector, then their cross product will be a cross b equals to 0 vector, because it's a vector quantity. Always remember, it is a dot, so scalar, it is okay 0. A cross b equals to 0, where a and b are non-zero vectors. So if vectors are parallel or collinear, first condition, or when we are solving these two, mod a mod b sin theta by using that concept I j k a1 a2 a3 b1 b2 b3, or we can write that concept also. I am writing in terms of x, ax ay az, also with the ratio bx by and bz. So we have either cross should be 0 vector, or their coefficients are in the same ratio or proportionate, or one more thing in vector we discussed. If two vectors are parallel or collinear, then it's the most important line. Then one vector can be expressed in terms of other vector, that line. So a vector equals to lambda b vector, or we can use this concept, or we can use that cross product. When two vectors a and b are non-zero vectors, then we can write their cross product, we can write their coefficient are in the same ratio, or one vector can be expressed in terms of other vector. Even we can write b in terms of a also, no problem for this. B of mu a vector. So if we are representing one vector in terms of other vector, that's the most important condition for parallelism of vectors or collinearity of two vectors. Okay. Now after vector 1 dot cross. In dot we have only one application, projection of vector, then projection vector. In cross, area of triangle, half of magnitude of a cross b. Then area of parallelogram when two adjacent sides are given by a and b, that is a cross b magnitude. If a cross b are given by diagonals value, then half of magnitude a cross b. In terms of diagonal, half of d1 vector cross d2 vector. Application of parallel. STP BTP is not in syllabus now. First, if we have to calculate normal first, DC, D and D are based question. Find the direction angle of line. Passing through 1 minus 2 3 and P. No. First case, find the direction angle of line passing through point P. Find the direction angle of line. That means find the angle alpha, beta and gamma for this line. So this here we have very easy 3D, because plane is not in our syllabus and the combination of plane and line is also very easy. So only basic direction, cosine, direction ratio, direction angle, these problems, and straight line. Again in straight line we will use that concept of vectors, dot or cross for angle and all type of things. So we have two type of form in both Cartesian vector, then two type of distance between lines. So for this, first try to find the PQ vector, PQ vector or QP vector. So that's why we have both type of cases. Now first find the line. So we can say for this solution, either we can start from PQ vector or we can start from direction ratio of this. So here either we can write PQ vector or QP vector. Here PQ vector is on given line. So that means PQ vector is what? OQ minus OP. OQ minus OP is what? Q minus P. So minus 2 minus 1 minus 3 IK. Minus 5 minus minus 7 JK. 1 minus 3 minus 2 KK. Now we have this vector. For this vector PQ vector we can find the magnitude of PQ also. That's the component with negative value, positive value, again negative value square. So we have this value root 62 now. Now we have unit vector is what? That is minus 3 by root 62 IK plus 7 by root 62 of JK minus 2 by root 62 of KK. Clearly here direction ratio of line or direction ratio or number of line. So here we can write direction ratio of number of line. In this line we have infinite numbers. Okay, direction ratio number. So we can write this coordinate minus 3, 7, minus 2 or other value also. Minus 3, 7, minus 2. That is our direction ratio ABC. These are the value of our ABC. So this is what A comma B comma C. Now direction cosines or DCs. This is our LMN. Again we have this type of value. Direction cosine may be on that side and that side. So we can take this value unit vector. So we can write this value minus 3 by. So I can write this value in terms of either plus minus, and for your understanding minus 3 by root 62, 7 by root 62 and minus 2 by root 62. Here one important point is what? If we are taking plus sign, then all value minus, plus, minus. If we are taking minus sign, that's the opposite direction of QP vector. Okay, because we are working on line. Here we are working on line. That means line may be in the direction along the PQ or QP also possible. Along the PQ, then same case. No need to take minus. But if only line, then we have to consider the case PQ as well as QP. So this is direction ratio number. It is not in that case only direction angle. Now direction cosine for this and direction angle. But in board examination we can write only one values also. Okay, only this value, then take plus value, whatever we are getting here according to our assumption. If we are taking QP vector, then answer is converse. If we are taking PQ vector, then answer is different. Only sign change. And direction angle is what? Now check. So direction angle is our first value cos inverse of minus 3 by root 62. Then cos inverse of 7 by root 62. And cos inverse minus 2 by root 62. Or we can write pi minus of this angle, pi minus of this angle, pi minus of this angle. So direction angle either this or 180 minus, so pi minus cos inverse minus minus plus, but I am writing same value root 62, first value alpha. So our direction angles are alpha, beta, gamma. So this value is alpha, beta, gamma is cos inverse minus 3 by root 62 or pi minus. Second value we have pi minus of cos inverse this value of 7 by root 62, and last value pi minus cos inverse minus is plus root 62 minus 3 by root 62, 7 by minus 2. Even in board examination we can write only one value, cos inverse, cos inverse, cos inverse. But it is better to understand the concept for line and for vector. In vector we have perfectly unique case. If we are taking PQ given, or we have to calculate PQ or QP, whatever. But in case of line, but if line is given as a directed line, that find the direction angle of line which is along in the point P and Q, where P and Q along PQ, then we have only one answer. That directed line, that means direction is defined in terms of PQ. Otherwise if line is not defined, then bidirectional, both sides. For this line we can apply arrow this side as well as this side. But what is the change? If this is a cap direction, then this is minus a cap. So only negative or opposite direction case. It is very basic case, line and vector. So vector every time unique. But even for line, in our NCERT book it is written clearly, the direction cosine of line is unique. And here after that, every time element with plus minus plus minus. If it is unique, then how plus minus plus minus? Clear? So plus minus, plus for that direction, minus the converse of that case, opposite direction. But normally for understanding we are saying that DCs and D alpha direction angles are unique, and direction ratio, direction number are infinite. Now first derivation based on one case based on alpha beta, if one angle is given and that type of case. So question number 2. Find the answer for this. If a line has direction ratios -2, 1, -2, then find its direction cosines. Which option is correct? A, B, C, D. Any other option? I have to write none of these also. Otherwise, accept none of these. E option. Fine. Find the answer. This direction ratios ABC are given, or we can understand that point like just like a coordinate of one point. Then find its direction cosines. Which option? What is the value of LMN here? D. Others? E. D. All of them. Here we have that value -2, 1, 2. So we know that this is what? A is -2, B is 1 and C is -2. First we can find the magnitude of that. That is A square plus B square plus C square according to the vectors. -2 square plus 1 square plus -2 square. That's a 4 plus 1 plus 4 and that's a 3. 9 root is 3. Now we know that L is what? L is plus minus A by root of that value. M is plus minus B of root of this value. N is plus minus C by root of this value. That's a square plus B square plus C square. It is also A square plus B square plus C square. Root of A square plus B square plus C square. Now we have L is what? Now for this, first we are taking this value -2 by 3, then 1 by 3 and the next value is -2 by 3. Normally we have this value -2 by 3, 1 by 3, -2 by 3. It is our in the same direction of this. So we have this value -2 by 3, 1 by 3, -2 by 3. That is our element. But we know that we have two type of sign, one with plus, one with minus. So first case with plus and second case with minus. So we have plus, so -2 by where is minus? If this is minus, then it is not minus. If this is minus, then all three minus. Now check. With plus, we have this sign. -2 by 3, 1 by 3, -2 by 3. With negative sign, we have this value 2 by 3, -1 by 3 and plus 2 by 3. So this is option matched with option D. And it is not percent. All plus, one first minus, all minus, first last plus, mid value minus. So option D is the based on this. Don't write answer in 6 format, 8 format. 1 plus, 1 plus plus, plus minus minus, plus plus minus, 2 2 2. Okay. So we are writing L is plus minus, M is plus minus, N. But every time, if we are taking one case with plus, then all plus. If we are taking one case with minus, all minus. Don't use that type of permutation combination 2 into 2 into 2. 8 type of cases in all of that, all direction. Only 2. This side or opposite of that. So opposite means we will take the negative of that case. Now next case. People like next second 90, 135, 40. 90, 135 and 40 degree with x, y, z axis respectively. Okay. So find its direction ratio. Don't here we have that one with the x, y, x, y, and z axis. What is the direction ratio of this line? You will first find DC, then find DC, then find direction, cosines and θs. Then you will find the DC's value first.
So 0 minus 1 by 2, 1 by, sorry, 0 minus 1 by 2, 1 by 2. What's it?
Minus 1 by root 2. You are saying 1 by minus 1 by 2.
Minus 1 by 2.
Minus 1 by root 2 plus 1 by 2. Not 0. So 0 minus was second. So first, these are the value of direction cosines. What about direction ratio?
We need to multiply by magnitude.
Where is the magnitude? So first that type of case. Now check. Here this is solution of this. Here the problem start with dA. Alpha 90. Next angle beta standard angle 135 and gamma standard angle 45 degree. These are our direction angles. So by this concept we can write cos alpha, that value is cos 90, it is 0. Cos beta, it is cos 135. In second quadrant cos is negative, so minus 45 is minus 1 by root 2. And cos gamma, that is cos 45 degree, which is 1 by root 2. Cos alpha, cos beta, cos gamma. Okay. Now, so these values are element, and here the element is 0, 1 is minus 1 by root 2, and the value is 1 by root 2. Clear? For this line, we have this type of case. For even, we can write the minus value also, but it will not work because 0 is neutral, it is plus, it is minus, so same, 1 is minus, other plus for that type. So we have element this one. Now what about the direction ratio of this case? For that type of case, what is the direction ratio? Now direction cosine is unique, so we can calculate this value. Or maybe the negative value of 0 plus 1 by root 2 minus 1 by root 2 is also correct for this case. Okay. But at this time we are writing only this one. What about direction ratio at ABC? Now check. For ABC, we have infinite ABC. Clear? First thing, we have infinite number of direction ratio, direction numbers. So by the concept of this, we can write what? Here we don't have any value. So multiply these value with any data 0, minus 1 by root 2 and 1 by root 2. Where lambda is what?
So it will be same.
So we can take lambda value as a 1 also. Lambda may be anything. So in direction cosine, BC is also a direction ratio. Clear? When magnitude A, when we divide that term by magnitude of A. So in that case, when lambda is magnitude A, it is cancel out magnitude to magnitude. The same point is there. So we can take any value, but in this case we can write where lambda is some scalar quantity. That is our answer. Or in terms of option, if we have option, then check which option we have according to this value. So one value is 0 definitely. And if I will multiply this case by root 2, for example, if I will multiply this case by root 2, So it is 0 into root 2. This is root 2 cancel out, minus 1 plus 1. So answer is 0 minus 1 plus 1 in terms of integer. Okay, then we can multiply it by. So like 0 minus 1, 1 is also there. They are infinite. Even I can write this value multiplied by 2. 0 minus 2, 2. Multiplied by any value 0 minus k. Multiplied by any value 0 minus lambda, lambda. So here we have infinite direction ratio. Normally we can write this one. So normally multiply by the magnitude quantity, whatever we are having here. So here root 2 to make it integer type of case. 0 minus 1, 1, 0 minus 2, 2, 2, 0 minus k, any value based on this. So this is our answer actual. We can write different answer. We have infinite direction ratio of this case. Clear? So direction ratio, if direction ratio is given in that case, right? If direction ratio by using this 2-point passing line, we can find first direction ratio by x2 minus x1, then directly we can find the DC. Okay. Second case, if we have dRs, then we can find DC also, because we have that root a square b square. But if we have DC and we don't have any vector or magnitude, in that case we have infinite answer. Every time we have infinite answer, but we cannot directly find the perfect answer according to the option or that type of thing, because here lambda we don't have information about this lambda, that which value we have to take, and lambda belongs to real number, so we can take any value. Normally we are taking this magnitude value. Now first case, important point, equation of line. Before starting the equation of line, first basic 2D line. Everyone knows the basic concept of 2-dimensional line. 2D normal line, we have 7 type of lines. In 7 we have here 3 cases in different. First line is our general line, ax plus by plus c equals to 0. Then y equals to mx plus c. Slope intercept on y-axis. Then 1-point form, y minus y1 equals to m of x minus x1. Line passes through x1, y1 and having slope m. 2-point form, we can find the value of m by using 2-point form, that is x minus x. The special case of 2-point form, when line passes through, when line having intercept on axis, like x by a plus y by b equals to 1. Intercept form, 1, 2, 3, 4, 5. Then normal form, x cos alpha plus y sin alpha equals to p. Where p is what? In this case, p is what? Perpendicular distance.
From origin to line.
P is the length of perpendicular distance from origin to the line. And alpha is what?
Angle between x-axis and perpendicular.
X-axis and perpendicular. In this case, we have that type of case. This case, so for this we have this line. This length, this is 90 degree, this is P, and this angle is our alpha. We don't have any information about the line and the angle of inclination of line. So if we have angle alpha, then what is the slope of this line? Or sorry, what is the angle of inclination of this line? Angle of inclination of this line. We have this equation, this blue line. What is the angle of inclination of this line? Very basic. Class 9, lines and angle. This theorem, exterior angle theorem. If we have these two angles, then this angle is the summation of these two. We have this angle alpha, this angle 90. So this angle is what? 90 plus alpha. 90 plus alpha is our actual theta. All this theta. Now after this 1, 2, 3, 4, 5, 6. That's one is parametric form. X equals to x1 plus r cos theta. And y is equal to y1 plus r sin theta. This is parametric form where x1 y1 is a fixed point. Theta is the angle of inclination of line and r is a distance from the point fixed point x1 y1 to the moving point x1 y2. That is parametric form. In line we have only 7 forms. It is general, it is slope intercept, 1 point slope, 2 point form, intercept form, normal form and parametric form. In parametric we have theta, r is parameter, theta is angle, r is a distance based parameter. Now, before starting this, same this case, we can write the equation of 3D, equation of line in 3D by using 2 point form, by using same concept, but we will derive each and every case. Now check here. Y minus y1 equals to y2 minus y1 divided by x2 minus x1 into x minus x1. We can take this value in denominator of this. So we can write this value as a y2 minus y1. Y minus y1, y2 minus y1. X minus x1 divided by x2 minus x1. This is the equation of line in 2D passing through two fixed points x1, y1, x2, y2. Same we can write the equation in 3D by generalize this concept. Where line passes through one point x1, y1, z1, x2, y2, z2. So for this we can write this by using z coordinate also, z2 minus z1. So that's the equation of line passing through 2 points, where one point is x1, y1, z1, other point is x2, y2, z2. No. But we will derive that case by a normal concept of our vector and that type of case. Now check first. Equation of line in normal 2D. First break. Equation of line in 3D. When a line passes through a fixed point A, so we have either position vector of A or coordinate of this. I am writing x1, y1, z1 or A vector. Okay. And is parallel to other line. Other line vector B. Again in this case we have 2 or 3 type of case. So that means we have to find the equation of this line in 3D. So this is our x axis, this is our y axis, this is our z axis. We have to calculate this equation. For example, so we have to calculate this equation in 3D, this line, where this line passes through one fixed point, any fixed point. For example, this dial of this passes this fixed point on this line. Now we have 2 type of cases. Either this direction is given, this direction, so this is direction of line, and this is one fixed point. Or maybe instead of this direction, we have other line for that direction is given. Now direction is what? Direction may be given in 3 format. Either for this line, we have direction angles alpha, beta, gamma with alpha, beta for y and for z, alpha, beta, gamma, or maybe direction cosine in terms of LMN is given, or maybe in terms of particular vector is given. That means direction ratio is given. So for this line we have line vector. Line vector means either we have complete V vector in terms of ABC, direction ratio is given, in terms of direction cosine Li, Mj, Nk given, in terms of angles given, that this line makes alpha angle, makes 30 degree angle from x axis, 150 from y axis, 60 degree from z axis. So in terms of alpha, beta, gamma, LM and ABC. So that means first we have to find this equation of line where we have this line. For this line we have only direction, or even full line is there. So we have to find the equation of line. That's the just a similar case of equation of line in 2D. Equation of line passing through one fixed point and having slope. Second case, y minus y1 equals to mx x minus x1. In this case we have this fixed point and we know that the angle of this line, so no matter angle of this line theta same, or some other parallel line angle theta. So here we have same type of cases. This direction is given, maybe this angle is given, or direct slope m is given in terms of tan theta, direct, or maybe direct this theta is given. So here we have, so for this one point A is fixed point, so we can make this position vector of this by using the concept of O. O is always 0 0 0 in 3D. We are taking this as x and y, normal xy plane, and this is outside this plane is our z axis. So this OA vector is our A vector. Position vector of point A is A vector, which is OA vector arrow. Same. Now here on this line we have to find this line. So consider any point in this on this line. Consider any moving point. So that random vector or random point, we are assigning that point as a R. Okay. So R means, so random vector is what? So we can write this vector as a R vector. So logically here OA vector is our A vector in terms of a single letter. And due to this concept, if this fixed point is x1, y1, z1, then I can write this vector as a x1 I cap plus y1 j cap plus z1 k cap. So one fixed point, and consider any point on line. So in 3D it is in space, so we have to consider point in x, y, z. So we can write that OR vector or maybe small r vector in terms of general case, any point on plane. In 3D xi yj plus z k. Here this xyz is moving. We can take r anywhere, no matter on right side or left side, if we are taking. Now by the concept of normal vectors, we can say this our actual line vector. Okay, this small l or capital, this is capital L or given line. For example, this L vector is given in terms of any either B vector, dr, dc, dA by using 2 points. This L, and we have to calculate this line vector L. We have to calculate this line. So here we can write by normal vector algebra this case. Even we have R this side, then no problem. Here we are making this vector. So we are making directed line segment for taking AR. So that means we are creating a one vector as AR vector where head is R, tail is A. So here we can write AR vector is what? By the concept of position vector of two vector. AR vector is the addition sum of OA plus AR equals to OR. OA plus AR equals to OR. So for that vector we have what? Vector AR vector is given by OR minus of OA vector. So that means logically we can write directly by using this case AR vector is OR minus OA. So I am writing R vector minus A vector, the position vector. Even we can write in terms of x minus x1, y minus y1, z minus z1. This AR vector clear by the normal vector concept. Now this AR vector and B vector, either both are, if we have the direction of this B vector, if we have this direction B, then we can say same. If AR vector is parallel to other line, here this is parallel to other line, we know that in terms of vector, parallel and collinear and even opposite are same. So we can say parallel vectors, or by the concept of parallel and collinear vectors here. Here AR vector is parallel to that line vector, and the line vector given in terms of B vector. So we can say AR vector is parallel to our B vector. Clear? Where B vector is what? Where B vector is our line vector. Even we can write the line vector also. Okay. So this is our line vector. Information about line. AR is parallel to B. We know that one vector, if vectors are parallel, then we have three type of case. Their cross should be 0. Second case, coefficients are same. Third case, one vector can be expressed in terms of other vector. For this case, one vector in terms of other vector. Now, A cross B 0, this one, or one vector can be represented in terms of other vector, where lambda is some scalar. So here by the concept of this, we can write AR equals to lambda B. By the definition of parallel vectors or collinear vector, we can write AR equals to lambda of B vector. AR equals to lambda B, AR vector by the definition of vectors, or we can say by triangle's law of vector addition. AR is our OR minus A, and OR minus A is R minus A equals to lambda of B vector. R vector equals to A vector plus lambda B vector. Here we have this information where our fixed point is a vector. So this A vector is our fixed point. We are considering any point R. This is moving point, and this is B vector. So this is given, and this we are considering any point. So R vector is what? A vector plus lambda B vector. This vector, this form is known as our vector form. Vector form of line in 3D where our line passing through one fixed point. The position vector of fixed point is a vector, which is x1, y1, z1, and the direction of what? This direction is what? Either line's direction or parallel line direction for this. So R vector equals to A plus lambda B. But if we have the B vector is given by ABC or LMN or alpha beta gamma, same A is given by, so here I am writing one more case. But now R vector is what? By that definition, R is xi in terms of xi, yj, zk. We already know that this A vector is what? A vector is our x1 I k plus y1 j k plus z1 k k. This is our first vector plus lambda. B vector is what? Now we have definition about B. Either in terms of ABC, in terms of LMN, in terms of alpha, beta, gamma. I have taken first case ABC. So this vector is given by AI plus BJ plus CKK. Now don't confuse this B vector with the coefficient of B. B vector containing the direction ratios ABC. So this B and vector B is different. In vector B we have three things: A, B, C are scalar component on x, y, z axis. That type of case. Now by using the concept of vectors, comparison of vector, we can write, take this to this side, or by using directly this, I am writing this side x minus x1 of I k plus y minus y1 of j k plus z minus z1 of k k. Now after multiplying this is lambda of A of I k plus lambda of B of j k plus lambda of C of k k. Now by the definition of equal vectors, means every component of I k, j k, k k should be same. So by comparison of these vectors we can write this value. Now by comparison of I cap, j cap and k cap. So we have three different things. First value x minus x1 equals to lambda A. Second value y minus y1 equals to lambda B. And third value z minus z1 equals to lambda C. By comparison of I cap, j cap and k cap. We can write this value x minus x1 by A equals to lambda, y minus y1 by B equals to lambda, and z minus z1 by C equals to lambda. By equating the concept of first case, second case, third case, for the value of lambda we can write all these three in this form. So from 1 to 3 we can write this value x minus x1 now x minus x1 by A equals to y minus y1 by B equals to z minus z1 by C. This is our vector form. Even this is also equals to lambda. Okay, so here when we have to represent any point on line, what we can write the coordinate of x, y, z. So this form is the equation in Cartesian form, equation of line in Cartesian form, this equation in vector form. Here we are using the vector terminology by comparison of I cap, j cap, k cap, then we have our relation in x, y, z. So this is our Cartesian form. But we can represent this R vector means the point of this. So x1 plus A lambda, y1 plus B lambda, and z1 plus lambda C is our this point. So we can consider any point on this line by using this concept a plus lambda b directly, or by in Cartesian coordinate geometry system we can write x is equal to x1 plus lambda a, y1 plus lambda b, z1 plus lambda c. This form is known as our Cartesian form. So this is our Cartesian form of line. Now here what? Line passes through fixed point x1 y1 z1, x minus x1 y minus y1 z1 z1. So x y z are moving point, x1 y1 z1 are fixed point, that means point coordinate of a fixed point, and ABC are what? ABC are the direction ratio of either the line itself or the parallel line. If lines are parallel, then ABC are same. Okay, for due to that concept of parallel line, A1 by A2, B1 by B2, C1 by C2. Even we can write the value of A in terms of A. We can write in terms of direction cosine is what? A. We can write this value lambda of A. Instead of ABC, we can write lambda L. This is not lambda, different lambda. Okay, A equals to some K times of L, K times of M, K times of M. Here we have equal to K, K cancel out. So here we can write ABC or LMN also. So in the second form for this we can write, if we can represent ABC in terms of x minus x1 cos alpha or L, y minus y1 equals to M, z minus z1 equals to M. So this is our form again in Cartesian form, where ABC are direction ratio of the given line or parallel line. Here LMN are direction cosines of the given line. Or even if alpha beta gamma is given, then we can take instead of LMN we can write cos alpha or cos gamma or cos beta. Cos alpha, cos beta or cos gamma. If alpha beta gamma given, then we can use this case. If LMN given, directly we can put this value. If ABC given, then we can calculate this case. But actual logic is what? Here in this case we have this. Here AR this vector, or even we can take R this side. So no matter AR or RA vector, this vector and this vector, still these two vectors are parallel or collinear also if we have same line. So in that case, in terms of parallel vector, here AR parallel. So by the definition of parallel vector, one vector can be expressed in terms of other vector. So we can have this. First, this is vector form, this is Cartesian form. Now, in this, one important point is what? Every time the coefficient of x, coefficient of y and coefficient of z should be plus 1. Coefficient of x, coefficient of y, coefficient of z should be plus 1. In that situation, the denominator part is always direction part. That means in terms of direction ratio, in terms of direction cosine, in terms of direction angle, alpha, beta, gamma. If x, y and z are coefficient of plus 1. Okay, if x, y, z having coefficient of plus 1 in that case. If we have 2x, 3y, 4z, first we have to convert into standard form. So this is standard form when one point is given and direction is given. So first case in our syllabus we have two type of lines only, right? 1 point and direction. This is 1 point and direction and 2.4. So that's the first case. We can convert this form into this, even this form into this by taking any constant lambda. X is equal to a. Now sometimes same form we have in different format. If this case is given in that pattern like r equals to b vector plus lambda of a vector. In that case our line, check, in this case our line passes through this fixed point and we have this direction. So whenever we have some constant value, some unknown constant, so multiplication with some unknown constant shows what? Direction of that line. Direction of that line or parallel line, both are same, no problem. But if we have direct simple vector without any unknown quantity, that is our fixed point. Even this same question is given by using this r equals to lambda of b vector plus a vector. In that type of case, r is moving point, x, y, z. This is our fixed point, this is our direction. In this case, this is our fixed point, this is direction. If we have that type of vector like r equals to a plus b, plus mu of C minus D. In that line, our line passes through this fixed point, where the fixed point is A plus B, and the direction of this line or direction of the parallel line is C minus D. So in that case, if we have any type of unknown quantity that shows the direction part, this shows that part. Just like y is equal to mx plus c, check. The coefficient of x when y is plus 1. This is our slope and this is intercept. Just like if we have only r value and one value without any scalar quantity. So this is our fixed point, this is our direction. Every time we have to remember this case. Now, first basic case based on this. First conversion from this form to this form. Many times directly in question it is given, like if this case is given in this form, r equals to 1 plus 2 lambda I cap minus 3 minus lambda of j cap plus 2 plus 5 lambda k cap. Okay. If one equation of line in vector form is given by this one, then find the direction of this line. What is the direction of this line? So for this case, first check. First we have to write this form into the standard form. Clear? So in that case, first take all lambda r vector. So first I cap, first case, then minus 3j cap, then plus 2 without lambda terms, plus 2k cap. This is first vector. Then take lambda. Here we have lambda, lambda and lambda. So 2ik, check, minus minus plus lambda. So 1, 2ik plus 1 into 2ik minus minus plus jk, and last k 5 plus 5k. Now check. So in that case, this line passes through one fixed point. The coordinate of that fixed point is I cap coefficient, j cap, k cap. So we can say this line passes through 1 minus 3 2. Okay, that is our point A or vector A. And the direction of this line is what? So in terms of direction ratio, I can write direction ratio is 2 1 5. In terms of direction cosine, we can write the value of 2. Direction cosine is lmn. Lmn is what? So 2 comma 1 comma 5 comma 2 square 1 square 5 square 5 square 25 4 5 root 30 root 30 root 30. So this is direction ratio ABC. This is direction cosine lmn, and direction angle is what? For the same line, cos inverse 2 by root 30, cos inverse 1 by root 30, cos inverse 5 by root 30. This case clear? Normal. So first form is what? Equation of line when line passes through one fixed point or having one position vector of one point, okay, and having the direction itself or having the parallel direction. Direction, we have direction in three format, either direction ratio, direction cosine, direction angle. First case clear? Now second, if line passes through two fixed points. In that case, if line is given, so solution of this part is this one. Clear? So this line passes through 1 minus 3 2 and direction ratio 2 1 5 with lambda. Cosine 2 square 1 square 5 square divided by lmn, plus minus also we can apply. And direction angle is cos inverse 2 by root 30, cos inverse 1 by root 30, and last case cos inverse 5 by root 30. We can cancel out here we are writing that. This is clear. So we have every information about line, and line passes through a fixed point. Clear this first case? So we can convert this form into this and this form into this. Okay. What the value of R means? Randomized vector on line or random point on line. So random point means moving point. So we have to take that point in the general 3D point XYZ. Every time that XYZ is changing according to the moving on the line. Clear first case? Now equation of line in 2.4. So we in our syllabus we have only two types. So that's the first form. Now B part for this. That first is 2 point and direction form. 2 point, second is 2 point form. Now check. Here we have 1 point. A 1 point is given by A, same just like class 11th. X1 y1, x2 y2. Other point is given by B. X2 y2 z2. We can take it's in a space. We can take in any of it, but we are taking here. Okay, x y z. This is our x-axis, y-axis. So now this case is given. So directly we can find by using, today's our first case was same question based on this. If we find the direction cosine, direction angle or direction ratio of this line which passes through two fixed points. So either we can write vector AB or BA, no matter. And we have, when we have the direction ratio or direction cosine by using this or direction angle, that means we have direction in any format. When we have this direction and we know that this line passes through 2 points, so we can take any point just like previous concept, r minus a equals to this direction we can use. So here we are making this case first. So consider any point on this line. Or this side or this side. Okay, I am making this point here. Consider any moving point R as a x, y, z. Or even we can take AB this side, R this side, R this side. So now check here the vector AR, this one. For this, first we have to understand the basic concept of our line position vector of this line. So we know first point. Then we have this second point, these two are given. And this R is our moving point. Logically here we have this definition first, this vector A is given. For R we can write OR as a R vector, and for B we can write this B vector. Now check, in this case and previous case we have different B. That B is the direction base, here B is a point base. We are using same symbol according to our book. OA, OB, ORB. Now check here. Here any vector we can take. For example, AR vector is parallel to our line vector. Same. Here AR vector is what? So AR vector we can take this vector as a. Here A is fixed, B is fixed, R is not fixed. So we are taking other vector B vector, AB vector also. AR vector is parallel to AB vector. Now we can write, if two vectors are parallel, then one vector can be expressed in terms of other vector. And by the definition of vector AR is what? OR minus OA. And lambda AB vector is OB minus OA. Position of final minus this. R minus A vector equals to lambda of B minus A vector. So here we have this definition, R vector equals to A vector plus lambda of B vector minus A vector. Here important point is what? A and B vector are the position vector of the fixed point. But in previous case, B vector is the direction vector of line itself or parallel. No matter. So here B vector is direction vector. Important point. Here A and B vector is what? both are fixed point. So by the help of AB or BA, we can find direction, angle, direction, cosine, direction ratio here. Now, this is our vector form. This is our vector form for 2 point. Now by using same concept lambda, we can put the value of R vector is what? Here we can write our OR vector, that is R vector in terms of xi plus yj plus zk cap. Okay. Same OA vector and OB vector, two vectors are given. That is small a vector or small b vector. It is x1 of I cap plus y1 of j cap plus z1 of k cap. Same, it is x2i plus y2j plus z2 k cap. By the help of this, we can find a b minus a. Now put it. Now in terms of Cartesian, we can write this vector as xik plus yjk plus zk. This side again we have that vector x1 of ik plus y1 of j cap plus z1 of k cap. But this is product with lambda. If I am writing AB vector, then B minus A. If I am writing BA vector, then A minus B. This lambda will change with negative value. So that value is x2 minus x1 I cap plus y2 minus y1 of j cap plus z2 minus z1 of k cap. We can write the same value. Now same. So x minus x1 of I cap here I am writing first x2 I cap plus y2 j cap plus z2 k cap minus of x1 I cap plus y1 j cap minus z1 k cap. Now take this vector to this side plus y minus y1 plus z minus z1. In RHS x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, and this value with the lambda. Now again we have two vectors by comparison of I j cap, I cap, j cap and k cap. So we can write this x minus x1 equals to lambda of x2 minus x1, y minus y1 equals to lambda of y2 minus y1, and z minus z1 equals to lambda of z2 minus z1. X minus x1 divided by x2 minus x1 equals to lambda, y minus y1, y2 minus y1 equals to lambda, and z minus z1 divided by z2 minus z1 equals to lambda. By the definition of lambda from first relation, second relation, third relation, equate all the value with different lambda, so we can write this value. Finally we have value x minus x1, x2 minus x1, y minus y1 divided by y2 minus y1, and z minus z1 divided by z2 minus z1. This value is what? This is our Cartesian form, or equals to lambda we can say. This is our Cartesian form. This is our Cartesian form of line. This is our vector form. So we have two type of form. 1 point direction form, 2 point form. 2 point form in vector form, 2 point form in Cartesian form. Directly we know that the difference of x2 minus x1 is what? For AB vector, we directly know that for this vector, A, B, C are what? That is x2 minus x1, y2 minus y1, or even we can take y1 minus y2. Same direction, z2 minus z1. So here that value of ABC, or even directly we can write in this case, if we have 2 points, then we can obtain the value of ABC is what? x2 minus x1, y2 minus y1, z2 minus z1. But it is the same line. So here we can take either AR, we can take BR, we can take AB vector, we can take BA vector. So in this case only 1 point is important for competition. r vector equals to lambda b minus a, so check first this value is what? Sometimes a minus b, even sometimes we have different point. This a vector can be replaced by b vector also. Instead of o vector I can take ob vector as a reference vector. AR, instead of AR vector I can take BR vector. So this A vector or B vector we can write in this case. Same for lambda B minus A or A minus B. So that B minus A, A minus B is set with lambda value, but we can take here B vector as a fixed point because both are fixed point. In this case x1 y1. Sorry, A and B. x1 y1 z1 x2 y2 z2. So here ABC is what? Here we have ABC, which is direction ratio for this. So it's a one important point. Done? Clear? Now. So if one line is given by x minus 3 4, y minus 5 1, z minus L1 is given, okay. L2 is given by x by 2, y by 3, 1 minus z by 5. For example, these two lines are given. First line passes through which point? First line passes through which point? First line passes through which point? L1. In this line passes through which point? Fixed point is what in this definition? In this? In second line passes through one fixed point. Which fixed point is there? Here we have x, y, z. X minus x1, y minus y1, z minus z1. So x1 is what? 3. Y1 is what? In this case is this one. X minus x1, y minus y1, z minus. Line passes through x1, y1, z1 having direction ABC. ABC are direction ratio. So first check x1, y1, z1 value where x, y and z having plus coefficient plus 1. Now here this line passes through which point? 3, 5 and this? Not 4. Take 2 common, z minus 2. Clear? So this line passes through 3, 5, 2. Okay, that is fixed point. Now what is the direction ratio or direction cosine or direction angle? First tell me the direction ratio. 4, 1, wrong. 4, 1, again wrong. 4, 1, 3 by 2. When we take this 2 common, this is 2 and we cannot write 2 by 3. We can take 2 into this way 3 by 2. Understand? So the direction ratio of this case is what? 4, 1, 3 by 2. Clear? So if we have direction ratio, then we can find DC also and angle also. We started class from DC direction ratio of this. So DC is what? 4, 1 and 3 by 2. Sorry, dr. In second line passes through which point? Second line passes through which point?
0, 0, minus 1.
0, 0.
Minus 1.
This is x minus 0, y minus 0, and here we have to take minus common. So z minus 1, and we can write this minus here. Clear? So this line passes through 0, 0, 1. Clear? 0, 0, 1. What is the direction ratio of this line?
2, 3, minus 1.
2, 3,
Minus 1.
not 5. 2, 3, minus 5. Clear? So direction, this line passes through 0, 0, 1, and direction ratio is 2, 3, minus 5. Clear? In next part, we will do some question based on this first. Conversion 1 to second, then two concept We have then angles between two lines and distance between equidistance and three concepts are according to